11.3 Inference about two means independent samples. So before we looked at dependent samples, so today we want to look at independent samples and moving forward with those pieces. Okay. All right. So first of all, we have looking at sampling distribution of two different means here with unknown standard deviations. Suppose that we have n mu in the standard deviation for our first sample and as well an unknown standard deviation for our second sample. Okay. If the populations are normally distributed and they're sufficiently large enough, so going back to that n1, n2 being greater than or equal to 30, then we can use this t-value to look for our pieces here. Okay. And so we want to be able to plug into those. Now, we are going to use a calculator to find all those things. So again, don't be scared of that big formula. We're going to work our way around it, all right? All right, so to test with these unknown standard deviations, one, the samples must be simple random sampling and through a completely randomized experiment with two levels of treatment. The samples are independent. And then again, the populations are either normally distributed or large, okay, but yet still not more than 5% of the population size. All right, so we still look at our mu because we are talking about mean here. We have our two-tailed, left-tailed, right-tailed. So again, those things don't change. We're still going to look at our level of significance and deal with those pieces as well. Okay. All right, so again, here is our test statistic, t sub 0. Looks just like that formula we looked at a moment ago, okay? And so again, it can fall within those pieces. And so if we are outside that, for two-tailed, we would reject. If we're less than the negative, we would reject. Or if we're greater than the positive, we would reject, all based on what tail we have, okay? Now our p-value, again, we would still need that test statistic, and all those things apply. But here it really actually says just use the calculator. And again, we will do that as well for those, okay? All right, now this is robust, but we got to be always careful with outliers and all those things, okay? All right, so here we're having this Space Lab Life Sciences. We're looking at some rats. Upon their return, they look at the blood cell, red blood cell mass on those things. And then we also have a control group. So we want to pay attention to those things. We have an alpha of 0.05, so we need to keep that in consideration. Now the question says, does the evidence suggest that the flight animals have a different red blood cell mass from the control animals? So is it just different? That means it does not equals when we're looking at those pieces, okay? All right, so they give us a table of values here, and so that means that we have data. So we're going to plug that stuff into our calculator and go from there. Okay, so let me clear that off. That's not what we need at this point. Now, in order to do this, this is our L1 and L2 here. Okay, so we want to go to L1, L2, and plug those things in. So you want to do that. So we go to L1 and L2 for those. Okay. Now, if I go to my L1 and L2, I've already done that for us, so we don't have to take up that time here. All right. Excuse me. All right, but what we are going to need is to look at how we're going to put this in, what do we need to use in our calculator, okay? And so when we do this, we're going to go to Stat, over to Tests. So just like we've done before, we're going to do Stat, over to Tests, and then we're going to go down to 2-sample t-test. Okay, or I guess that's really samp, not sample. So let me take that LE off there, sorry. So samp for sample t-test. Okay, so it's number 4 on my calculator. All right, so then we're going to fill in the corresponding information. Now we have data. Okay, so that means we want to select data here on this because we have data in L1 and L2. Now our lists are L1 and L2. So typically that's what's going to be in there unless we were to do something somewhere else. We would change that, but typically those are L1, L2. Our frequency is 1. Okay, so we've done those pieces. Now, we stated that this was a does not equals. Okay, for those. Now this pooled piece, we're always going to select no for pooled. So we don't need to change that. Just select no every time with those. Okay, and then we're going to calculate. All right, so when we're looking at our pieces here, they go through and do all these other things, but they start working it by hand. Now again, you can see that we did a does not equal for these. And so we need to pay attention to those items, okay? So when they do their test statistic, T, they get negative 1.437. Well, what do we get right up here at the top? Negative 1.437 when we round, okay? And so that calculates it right there for us when we put those in, all right? Okay, now when we compare that against what's going on in our pieces, because we have a significance of 0.05, okay, we would go and look at those. Now it's a two-tailed because it does not equal, so we divide those by 2, and so we get our T of 0.025, and we'll have both negative and positive. Well, our test statistic is inside those, and so that means that we do not reject the null hypothesis. Okay? All right, now what about the p-value? Well, again, they go through hand, but they're going to go to the calculator as well here for all of this, for our pieces. And we see that we're going to get this p-value up here of 0.16, okay, for those. All right, and so that's what they get as well. After doubling these, we have a value between 0.1 and 0.2 for those, okay? And so as well in the calculator, their StatCrunch got the same answer that we did here. And so, so our p-value is 0.16. Well, that is greater than 0.05, okay? And so therefore, we do not reject the null hypothesis. Okay, so all those words that they were saying in there get us to the same place, right? All right. Now, you'll notice here they have degrees of freedom. The calculator does calculate things a bit differently. It's more off this formula. For degrees of freedom, you're not going to have to do that. You can use the calculator there for those pieces on that, okay? All right, now what about confidence intervals? So this was our test here. So now we want to look at the interval and see how to do those, okay? All right, so here's our official formulas for our intervals. We have our lower bound and our upper bound, and paying attention to the details on those, okay? All right, so here are our, here's our question. We have some Republicans versus Democrats, and of every tax dollar that goes to the federal government, how many cents of each dollar would you say are wasted? So this is just their opinion on what those things are. Okay, now the Republicans said 54 cents with a standard deviation of 2.9, whereas the Democrats said 41 cents with a standard deviation of 2.6 on those pieces. Okay. All right, so again, we want to look at all those pieces and see what's going on there, okay? So for our interval, we are again going to go into stat, over to tests, and then down to 2 samp t interval, okay? 2 samp t interval for this one. Now, they've already given us all of our pieces. They give us the mean and the standard deviation, so we don't have to worry about all the other things going on there for that, okay? All right, so let's go into stat. We're going to move over to test. We're going to do 2 sample t interval. This time we have the stats, okay? We don't have the data, we have the stats, all right? So our first one was the Republicans. So for our Republicans, we see that we have here 54 cents, so a mean of 54 cents, and then a standard deviation of 2.9 cents for those. Okay, so 54 and 2.9. And there were a total of 513 Republicans. Okay, so we can see that right up here. Okay, now for our Democrats, we see again there are 513, but they set a mean of 41 and a standard deviation of 2.6. So their mean is 41, 2.6, and then there were also 513 of them. Okay. Now we want a confidence level here, 95%, so 0.0 or 0.95. Again, we're always going to select no for pool, and we're going to calculate. And so we can see right up here that we have our interval for those. Okay. All right. And so they go through again. They do all this by hand on these pieces. But we get 2.7 for our lower bound. Well, that's exactly what we had up here when you round. And then 13.3. Again, that is what we have up here when we round. Now here is showing us a different program. They get the same thing that we had. Okay, and so that means we have 95% confident that the mean is between 12.7 cents and 13.3 cents higher than the mean of the Democrats for the Republicans there. Okay. Now we talked about this pooled. We're always going to do no for those things, so we're not going to worry here about these pieces. So we're not going to worry about doing any pooling. All right. All right. So those are the things that we're going to need here for 11.3.